Let's start with something that should make anyone using AI assistance uncomfortable. A researcher going by Vavkamil published a write-up this week on our netsec called the Memory Heist, detailing how they tricked Claude into leaking its deepest, darkest secrets from conversation memory. The attack leverages prompt injection, the same class of vulnerability that's been haunting large language models since ChatGPT launched. But this one targets the persistent memory feature, the thing that lets the model remember context across sessions. The researcher demonstrated that carefully crafted prompts could coax the model into regenerating stored conversation fragments, including sensitive information from prior sessions. The implication is clear. If you're using AI assistants with memory enabled for anything confidential, business strategy, code, personal details, that data is recoverable by anyone who can inject text into your current session. Anthropic has been notified, but the fundamental architecture of persistent memory makes this a hard problem to solve. Treat AI memory like shared cloud storage. Don't put anything there you wouldn't want an adversary to read. And this one affects millions of households. Researcher and AI Adum IO21 dropped a post titled "No Shark is Safe," revealing that millions of Shark brand robot vacuums are vulnerable to remote code execution. Shark is one of the biggest vacuum brands in North America, and their robot vacuums connect to home Wi-Fi and phone apps, which means they have a network stack and firmware update mechanism. The vulnerability allows an attacker on the same network to execute arbitrary code on the vacuum's embedded Linux system. From there, the vacuum becomes a foothold, a persistent presence inside your network that can pivot to other devices. The attack surface is worse than it sounds because these devices run continuously, auto-reconnect to Wi-Fi, and users rarely update their firmware. If you own a Shark robot vacuum, check the app for firmware updates immediately and segment your IoT devices onto a guest network. A vacuum should never sit on the same VLAN as your laptop. Next, a vulnerability in Dell BIOS that breaks a security control most people assume is solid. Researcher Saad Kodidrepeft published CVE 2026-40639 on our netsec, showing that Dell BIOS passwords use weak XOR encryption that can be recovered from a spy flash dump. BIOS passwords are meant to prevent unauthorized changes to firmware settings, boot order, and secure boot configuration. Recovering them shouldn't be trivial. But the XOR implementation means anyone with physical access to a Dell machine, or anyone who can dump the SPI flash via a remote management interface, can extract the admin and user BIOS passwords in seconds. This matters in enterprise environments where BIOS passwords are a layer of physical security for laptops and servers. If an attacker recovers the password, they can disable secure boot, change boot order, and install a persistent rootkit below the operating system. Dell has released a patch. If you manage Dell hardware in your fleet, check your BIOS version and apply the update through Dell Command Update or the support site. One of the highest bounties this week went to researcher Swingler, who earned $13,337 for a confused deputy attack against Google's identity provider. The post on our netsec describes a universal account takeover via device code flow hijacking. Device code flow is the OAuth mechanism used when a device can't easily render a web login page. Think smart TVs, CLI tools, IoT devices. The user visits a URL and enters a code to authorize the device. The vulnerability allowed an attacker to hijack this flow and obtain tokens for the victim's Google account without their consent. Universal means it affected any Google account, not just specific apps or tenants. If you use Google as your identity provider, and most organizations do, this was a one-click compromise of your entire identity layer. Google has patched it, but the write-up is worth reading because device code flow is an often overlooked attack surface in OAuth implementations. Audit your own flows. Make sure device codes expire fast and are bound to the requesting device. Now, for the most dangerous web vulnerability this week. Researcher Mempodipper published Mempodipper, Cello pre-authentication remote code execution chain in WordPress core. Assigned CVE 2026-63030. Pre-auth means no credentials needed. Remote code execution means full server control. In WordPress core, WordPress powers over 40% of the web. The technical details involve a logic flaw in WordPress's authentication and authorization handling that, when chained with a deserialization gadget, yields arbitrary PHP execution on the server. There is an open source scanner available to check if your WordPress instance is vulnerable. If you run WordPress, patch to the latest version immediately. This is the equivalent of a 9.8 CVSS. Every unpatched WordPress instance on the internet is a shell waiting to happen. And if you're running a managed WordPress host, confirm with your provider that they've applied the patch. Don't assume your hosting provider is fast. Many small hosts take days to push core updates. Run the scanner yourself. Staying with Mempodipper, the same researcher also dropped a ServiceNow Sandbox Escape this week. The post on netsec describes a pre-authentication remote code execution in ServiceNow's Sandbox environment. ServiceNow is an enterprise platform used by thousands of large organizations for IT service management, HR, and customer service. The sandbox is supposed to be an isolated environment where developers test code safely. The vulnerability allows an unauthenticated attacker to escape the sandbox and execute code on the underlying ServiceNow instance. This is significant because ServiceNow instances often contain sensitive employee data, ticket histories, internal documentation, and access credentials. A pre-auth RCE means an external attacker with no foothold can compromise the entire instance. ServiceNow has released a patch. If your organization uses ServiceNow, verify that your instance is updated. And if you have a public-facing ServiceNow portal, treat it as a high-value target. These systems are often overlooked in Penta's scope, but they're gold mines for an attacker. Next, a vulnerability that breaks a fundamental boundary in operating system security. A post on r-netsec details a vulnerability in the Realtek network driver that allows DMA controller abuse from user mode, with no additional hardware or driver required. DMA, direct memory access, is a hardware feature that lets peripherals read and write system memory without going through the CPU. It's supposed to be restricted to kernel mode and trusted hardware. This vulnerability lets a regular user mode process program the DMA controller to read and write arbitrary physical memory. That means bypassing the operating system's memory protections, reading kernel memory, extracting credentials, or modifying kernel data structures. The fix requires a driver update from Realtek, but the deeper issue is that DMA protection in consumer hardware is often incomplete. If you're on a system with a Realtek network adapter, check your driver version. And in enterprise environments, consider enabling IOMMU and VT to add a hardware layer of DMA protection. Here's one for the defenders. A write-up by Reese Downing on netsec describes a bitmap steganography dropper delivering a syncrat through a 4-stage payload chain using pixel-level encoding. Steganography is the practice of hiding data inside other data. In this case, the malware payload is encoded inside the pixel values of a bitmap image. The image looks normal to a human and to most antivirus scanners, but when rendered and processed, the pixel values are read as binary data and reassembled into an executable. A syncrat is a remote access Trojan commonly used for persistent access, keylogging, and data exfiltration. What makes this notable is the evasion. Traditional signature-based detection misses it because the payload never exists as a file on disk until the final stage. Defenders should be monitoring for anomalous image processing behavior, processes that read large bitmap files and then allocate executable memory. And if you're running EDR, confirm your vendor covers steganographic payload extraction. Many don't. Now to Kubernetes and a vulnerability in one of the most popular policy engines, Kyverno. The CNCF graduated policy engine for Kubernetes disclosed CVE2 the root sur the source 3. Tenos 54523 this week. The vulnerability allows cross-namespace privilege escalation through a string manipulation in namespace policy definitions. An attacker who can create or modify a Kyverno policy in a single namespace can craft the namespace string in a way that grants access to other namespaces, including kubesystem. From kubesystem, you control the cluster. Full cluster-wide privilege escalation from a single namespace is a worst-case scenario for multi-tenant Kubernetes. Kyverno has released a patch. If you run Kyverno in production, update immediately and review who has permission to create and modify policies in your clusters. Policy engines are trust boundaries. If an attacker can control the policy, they control what's allowed. Treat Kyverno policy management the same way you treat RBAC. Restrict it, audit it, and monitor changes. Finally, a trend piece from Ardbetavis hacking that ties several of these threads together. A post titled AI data centers are being built faster than they can be secured highlights a growing problem. Hyperscalers are racing to build AI infrastructure, massive GPU clusters, training facilities, inference endpoints. The security lag is real. New data centers come online with default configurations, incomplete network segmentation, and management interfaces exposed to internal networks that are already compromised. We've seen this pattern before with cloud adoption, with IoT, with every wave of infrastructure expansion. The build speed outpaces the security maturity. The takeaway for security professionals is that AI infrastructure is a new attack surface. GPU clusters run management APIs, training pipelines pull code and data from untrusted sources, and inference endpoints process adversarial inputs. If you're securing AI workloads, start with the basics. Segment the training network, restrict management plane access, and scan training data for prompt injection. The attackers are already looking at this surface. You should be too. That's all for this episode. Stay sharp.